All right, guys, welcome to the Analytics for a Better World section on Power BI. Just a little bit of background on myself and the organization. I work for a company in the Netherlands, in Eindhoven, called Pipple. Pipple specializes in all things data engineering, data science. A little bit about myself. I'm Tiaan Conradie. I'm originally from South Africa. I moved to the Netherlands 6 years ago, and I've been working here as a software and data engineer for the last 6 years. And of course, in data engineering and data science, one of the tools in your data toolkit is definitely Power BI. So I'm looking forward to present and assist you guys with getting to know a little bit more about Power BI. I really hope that I saw that in the Slack chat. I saw that some people had some issues installing Power BI on Macs. Also some people that had some trouble installing it due to permission settings from your IT. So I hope that everyone sort of came right with a workaround and a solution, and that you've got Power BI desktop installed. So just some of the things that we'll be covering today. I would like to go through first the data set that we've developed. Hopefully everyone's got access to that. We'll do a little tour through Power BI. We'll click through to just sort of see all of the different interfaces, all of the different things that we've got available in Power BI to do our analysis. We'll go through a couple of visualizations. There's quite a lot available. Some of that I will be demoing for you guys, and also give you guys the opportunity to develop or create your own visualizations with the end goal in mind of building a sort of interactive dashboard. Something important that we're going to cover as well is Power Query, which is sort of the underlying basis of Power BI and how we actually transform our data to make it available for analysis. We'll go through some filtering and slicing, measures versus calculated columns, which sort of falls more under our data modeling section. And then I'm going to give you guys the opportunity to sort of use all of the initial things to build an interactive dashboard, and then we'll go ahead and summarize it all. So I always think it's with these demos and on Power BI, or really any sort of demo that you use, is to just get a good understanding of the data set that we're going to be using. I think that's always useful to sort of get a picture in your head of sort of the scenario that we're going to be making use of to demonstrate all of the different functions that we've got in Power BI. But actually, before we get into the data set introduction, I also want to just talk a little bit about what Power BI is as a tool in your toolkit as a data engineer or as a data scientist. So Power BI, short for Power Business Intelligence. It's a business intelligence tool. It supports a wide range of data connectivity. So you can connect to a really wide range of different data sources. The example that we have today, maybe I think you guys have downloaded the data set already. We're going to be making use of an Excel workbook. But there is a lot more that it has available that you can connect to. And we'll go through a couple of those. It's also extremely useful in data transformation and data modeling. So taking our raw data set and making some changes to those data sets, because it's quite rare that you get a data set and that you're perfectly happy with what it has to offer. Sometimes we as data scientists, we'd like to add some more information or parameters to our data set to give us a better insight of the problem at hand or the scenario at hand. And then, of course, the fun part of Power BI is always the data visualization part of things, where we can make our graphs and visualize those as a dashboard. And then, of course, we won't be doing too much of that today, but something which is important is that Power BI also gives us the opportunity and facilities to make all of our insights available to a wider range of different users. So, for example, you can make a Power BI dashboard, and you can make that available to as an embedded dashboard on a website, for example, or you could make it available as part of an application on your mobile phone. You could also make it available for your colleagues at work, where you guys can collaborate and work together on a Power BI report to get insight into a specific problem. So it's extremely useful, as it can connect to a wide range of data sources. It provides tools that we can use to transform and get better insights as to our scenario or problems at hand. And then it also provides us with the facilities to make that data available in a wide array of different manners. All right, so let's get into the scenario that we've got at hand today. So the data set that we've got is basically a scenario where a company or an organization, I suppose the semantics of that is not too important, but we've got an organization that has or that conducts a lot of tests on air quality across Europe. So we have a bunch of testers. They go out all over Europe, and they go to all the different cities, and they conduct a series of tests on the cities to determine what the air quality is in these different cities. So, yeah, an important note here is that it is a dummy data set which we have created. So none of the numbers, the names, or anything like that actually corresponds to real individuals. And also if you see a bad air quality in your local city, it doesn't mean that it's actual bad quality in your local city. These are all dummy figures purely to illustrate sort of the way in which we can use Power BI to make these analyses. All right, so hopefully you guys all have the Excel sheet in front of you, and I'd actually like to just bring the Excel sheet up onto the screen share before actually going through the slides. I find it a little bit easier to talk through the data set that we're going to be using simply by using Excel. It's a little bit easier. So you should see 3 different tables in Excel. We've got a DIM test, DIM report, and fact test. So our first table, the simplest one that I want to have a look at is DIM test. So what does this tell us? We have a test ID, a test type, and the cost per hour of the specific test. So we've only got 5 different types of tests. So these individuals that go out all over Europe to go and do all their tests, they have the choice of 5 different tests. It can be a particle pollution test, ground level ozone test, sulfur dioxide test, carbon monoxide, or nitrogen dioxide test. They've got 5 different tests that they are able to conduct. If you go to the DIM report, you will see a little bit more information on the scenario at hand. So we have a set of measurement IDs, and that corresponds to a test which was conducted on a specific date. It was conducted in a specific city. In this first row example, we have our measurement ID BN 2011, the number at the back. The measurement date was the 1st of January 2011. It was conducted in the city of Stockholm in Sweden. And we've got a latitude and a longitude for exactly where that test was conducted. And that's going to be a little bit, that's going to become of importance a little bit later when we look at some of the types of visualizations we want to do in Power BI. Very important. And in this specific city or in this specific region, the air pollution penalties are high. Our air quality index, as measured by the test which we conducted, you can remember one of the 5 tests, was determined to be 44, and the air quality was rated as good. So these are just all of the different tests which were conducted on a specific date. Now there's one more table, which is fact tests. So this gives us a deeper insight into the tests that were done on an individual date. So with these measurement IDs here, you will see that sometimes you have more than one test that was actually conducted on a specific date. So for example, if you look at this measurement ID here, you'll see that we conducted 2 different tests there. It was done by 2 different people, Gracie Hicks and Owen Howell, and the costs of the tests on that day were $5,400 and $5,600 respectively. So you can sort of think about that cost of test as the hotel costs, the transport costs, the whatever costs these testers incurred as the final cost of the test on that day. So that's important. So you got your three tables, your DIM test, DIM report, and fact tests. And all 3 of these tables, you might have noticed already, they all have a certain connection to one another. You might have noticed that the measurement ID occurs in the DIM report. It also occurs in the fact test. And also the test ID occurs in the fact test table. So these are just important to keep in mind for now. We'll get into how Power BI understands these relationships just now. All right. So if we look at DIM report, the measurement ID here is our identifier. It is a unique key in this table, so it never occurs more than once, and we call that our primary key. The rest of the columns are all just features and properties of a particular measurement ID. Dimension test, as I explained, gives us just a little bit of information about the cost per hour and what the test is. So what test do these guys conduct? And then we have the fact test table. And so for this one, you'll see that the combination of measurement ID and test ID for these will be unique. So as an example, if you look at, and I kind of touched on it a little bit earlier already on going through the test table, you have a measurement ID in your dimension report table. So we have BN 2011-281974 on the 1st of the 4th, Birmingham, United Kingdom. And so what exactly happened on this day? 2 tests were conducted by Gracie Hicks and Owen Howell. Which test did they conduct? They conducted carbon monoxide and nitrogen dioxide tests. So that's the tests that were conducted. So that just shows you that these 3 tables, they do have some sort of a connection to one another, and that's important to remember just for now. We don't have to. Yes.
Question: what does BN and AZ mean in the measurement ID?
Those are just randomly generated numbers. So for the purpose of understanding Power BI within the context of this thing, it's not important to know exactly what for example, the measurement ID BN 2011 means. It doesn't have any significance. For example, you also don't need to know what a carbon monoxide test is or a nitrogen dioxide test is. It's purely for the one thing that's important to take away from this specific example is that there is a connection between these 3 tables. And we connect them with the measurement ID. As you can see, if I just use this laser pointer, you'll see that this ID here is exactly the same as this ID over here. And that tells us on this specific day, these were the individuals that conducted the test. So, but the number itself is not really important. What's important is to know that there is a relationship between these 3 tables. I hope that answers the question.
Thanks.
It's also just to get an idea of what the data set is that we're working with. So we've all got a sort of picture in our head of what we're trying to sort of understand. All right. So if we think about a possible use case for this data set and where Power BI can fit in to try and get a better understanding of what has happened over the last few years with these tests we've conducted. We can think of something like using the data set and Power BI tools. We can create a dashboard that provides information about, for example, the number of tests per tester. So we saw that in the previous example, we had Gracie Hicks and Owen Howell that conducted tests, but as these individuals in an entire firm, how many tests do they, for example, conduct over a certain period of time? We can also think of things such as which tester costs the organization the most money. That can be an interesting statistic to think about. We can also think about, since we have latitudes and longitudes and cities and countries, we can also look at which tester, for example, traveled the most out of all the testers that we've got. So there's a lot of different use cases we can think of. We have a lot of data to play around with, but just the one use case that I'm going to use to sort of go through all of the different graphs would be something similar to, or something like looking at the number of tests per tester, the regional costs and information on specific tests. And perhaps we also get the instruction that it would be great to see some geographical information like maps as well. And Power BI provides us with some really nice tools to make use of, that we can actually depict things geographically as well. All right, a quick tour through Power BI just to give you guys an idea of the things that we'll be working with. Of course, we will also be touching on a lot of these clickable options in Power BI as we go through, as I demo how to create these visualizations and how we write queries in Power Query. I'll explain each one of them as well. But at a first glance, you will see that, yeah, we've got a similar look and feel to most Microsoft products.
Fine. Sorry to interrupt.
Yes.
It's a bit difficult to read. Is it possible to make the screen a bit bigger, the Power BI screen a bit larger?
I can't make that bigger, but what I can try and do is I can try and, let's see. Can you tell me if this might be better if I use the actual screen like this? Does that work better?
Yeah, I see you nodding, so yes.
Yes.
Thanks.
Okay. All right, so then we might have to use this for now instead of the slides. But good thing is most of the demos and stuff all happen. We've got a ribbon at the top here, which gives us access to some functions. And the first set over here, let me rather use these. I cannot use the highlighter now because that's not going to work because I'm not using the slides. But the first part of the ribbon is the data component, and this is important for loading in our data. It allows us to access a wider range of different data sources, and perhaps since we're actually on it now, we might as well click and have a look at it. So this is usually the first starting point for most of us when we're working with Power BI, because it allows us to get our data. So for today, we're going to be making use of the Excel workbook. You guys don't have to click on anything just yet. I'm going to give you guys an opportunity to do that just now. But there's lots of other different areas as well that we can access. So you could make use of, for example, just a normal text file, XML, JSON files, Parquet files. And I think that you guys will also be doing a course also still on SQL, but you can also connect directly from Power BI straight onto an SQL database, which is a really nice function. And then, yeah, these sources are actually pretty much updated at every single Power BI upgrade that Microsoft releases. And as more applications become available, these are constantly maintained and updated. So you can also, for example, I think maybe a lot of you have heard of or even worked with Microsoft Azure. It's a really big cloud environment where a lot of data processing takes place. So you can also
connect directly from Power BI straight onto your Azure resources with the correct credentials, of course, and then you can use data, or you can do your data transformations and data manipulation in Power BI. So this really gives you an idea of the vast amount of, I think even LinkedIn sales, for example, there's really a lot of different possibilities that you've got in order to have access to data. And if you compare that to, for example, just Microsoft Excel, usually, it's really an immense amount of diversity when it comes to what data you're able to process. All right, so that's really all about this first part of the ribbon, which is our data ribbon. Another important part is the transform data. And you'll see there's a little subscript there, it's called queries. And this will take us directly to the area called Power Query, which sort of makes up the basis of Power BI. And we'll get into that a little bit later. So for now, it's just good to know that this gives us access to that. We've got some options here for creating custom visuals on our dashboard. For example, a text box with some more information about what a graph depicts, if you wanted to do something like that, or some custom visualizations. And then we also have the option to access some calculations, which is also something we'll do at one of the sections in the course, where we do some data modeling on the tables that we've got. And then we have on the right-hand side here, this is probably the area where you'll be spending most of your time when you're working with Power BI. So if you, for example, click on a graph, you'll see some things change here, but all of your control of your visualizations pretty much occur on this right-hand pane. You've got filters where you can assign custom filters to your graphs. So perhaps sometimes you want to limit what it is you want to make available on a specific graph, and that can all be done here at filters. Your visualizations gives you access to all of the different visualizations that Power BI has to offer. So just as a little example, this is a live chart here. So you can click through and have access to all the different types. I'm not sure this would be a very good example. That's maybe a bit not the correct use of a chart, but it gives you an idea of that. It's quite quick and easy to change between charts. But all of your charts you'll be inserting from the right-hand side here, and at the bottom here is where you actually have control over your different axes and adding in data. So you can decide what you want to put on your x-axis, your y-axis, what you want to configure as your legend, and what additional information, for example, you want to provide on your tooltips. But we'll get into that a little bit later. And then lastly, on this section here is your 3 tables. So you might notice that these 3 tables also correspond to what you've got in your Excel sheet. You've got DIM report, you've got DIM tests, and you've got your fact tests. So these are the 3 tables that we had in Microsoft Excel, but that data is now present in Power BI. So this is generally where you would be starting before you start doing all of your data transformations. Another important navigational tool in Power BI is your 3 different views. So you've got the report view, and in your report view, you can create, visualize your underlying data, as we did in this example here. So we've got this graph here, and that will be shown in your report view. Then you've also got the table view. So your table view is, you'll see it looks pretty similar to Excel, but that gives us a good view of our underlying tables. So in this one, we've got our fact test table, we've got our dimension test table. This should all look fairly familiar from the quick little Excel chat we had. and we've got our dimension report table here. So this gives us access to all of these tables to have a look at them, but we can also use this as a starting point to, for example, do some measurements or add new columns if we want to, which we'll do at a little bit of a later stage as well. For now, our focus is just that this is a view that gives us access to the tables. So table view, and that's our report view. And the last view we've got is the model view. So a little bit earlier on, I mentioned to you guys that it's important to just remember for now that there are relationships that exist between these tables. Now, Power BI will, if your columns are named the same across the different tables, if your columns are named the same and there's a relationship between these columns, it will auto-detect these columns. So what do I mean by that? So what I mean by that is if I click on this table here, you'll see that we've got a column test ID and a column test ID here. So Power BI is going to make the assumption that there is a relationship between these two tables, which we can then use at a later stage. And the same with this side here. So if I sort of hover over it, it immediately picks up that there is a relationship in terms of measurement ID between fact tests and DIM report. So that is quite a nice feature that it automatically detects it, but it's good to also remember that it only detects it if your columns are named the same. So that can either be something good or it can be something a little bit of a pitfall as well, because if you've got columns across tables which are named the same and there is no relationship, then that's something to keep track of. And if you, for example, have a relationship and your columns are not named the same, then it's up to you to add that in. But we'll get into that at a later stage. For now, it's just important to note that Power BI detects these relationships. And yeah, if you guys at this point don't understand any of or not the relationships, like I explained it in Excel, you can see it visually here in Power BI. Yeah, please ask if that is not clear how these relationships sort of work. All right, got to go back to the slides quickly. All right, so we've gone over the ribbon. We went over the 3 different reports. You got your report view, your table view, and your model view. We went through our filter pane briefly. We'll get into the more details of that when we look at some of the examples. We have our visualizations pane, our data pane. Right. So as I mentioned earlier, maybe you can guys actually have a good look at this now. I don't know if it was a bit too small, but this is our get data pane where we've got access to loading different data. We've got the transform data tab, which will be important but later on, where we can make changes to our existing data sets using Power Query, and access to creating measurements, which falls under the field of data modeling. Then in the modeling ribbon, we can go to manage relationships. That simply takes us to the model view. This also just gives us access to the measurements and adding of columns, and yeah, managing our parameters. So parameters we won't be looking at too much today, but it might be good to use an example a bit later. So I'll explain a bit about parameters when we get into Power Query. All right, so I'm not going to go through all of this again because we explained it already. Went through that. And explain that with use of the Power BI. Okay, so let's create our first visualization, and I'm actually going to share my screen, and I'll do that from scratch. Let me just see, where is my, there we go. All right, so the first thing about visualizations is, of course, we need to first load in our data. And I'll explain this part as well. All right. So first, visualizations, topics to demo. So let me open this up. Okay, so this is an empty report. It's not the one that I used for the example earlier on. So I think that for you guys, if you guys have Power BI Desktop installed, you should have access to a blank Power BI interface like this as well. You guys don't have to do or follow anything for now. But for now, just have a look, because after this, you're going to do a little example by yourself. So maybe for now, it'll just be good to have Power BI Desktop open so that you guys can get into it and sort of have a look at what I'm doing while I'm doing it. All right, so like I said, the first thing we're going to do is we don't have any data on the right-hand side here, so we need to make sure that we've got some data first. So we click on the Get Data tool, and I would actually like to just go back to this. And so, like I said, we have a choice of a lot of different data sources, and as you might have seen on GitHub, we're going to be making use of an Excel workbook. So once we click on Excel workbook, click Connect, it should prompt your Windows Explorer, where you can connect to airqualityeurope.xlsx. Oops, sorry, this file's in use. It's because I used it for the demo. Just give me a second, close that. Right, it's connecting. Okay, so we have the option here, once we've clicked on the Excel sheet, is we can load one table at a time if we want to. Because sometimes you won't use all of the tables in your analysis. In our case, we're going to use all three of them. So I'm going to just load all three of them so you can get a preview of your data. Dimension tests, that should look familiar. And we're going to load our fact test table. You push on load. And Power BI is going to load. In the technical term is that it doesn't really load the data. It runs a query against your Excel sheet, and then it pulls all of the data into the Power BI environment. All right, great. So now we haven't created anything, but on the right-hand side here now we can see we've got our DIM report, DIM test, and we've got fact tests with all of the different columns, which we can now make use of for our analysis. So the first graph that we want to, or visualization we want to start off with, is something like this. We want to have a look at how many tests were conducted by each one of the agents. So the individuals that conducted the tests, not only the number of tests, but we also want to break that down into how many of each one of these specific tests they did. So your particle pollution tests or your carbon dioxide test, we want to get some information on that. So how can we do that using Power BI? So let me go ahead with this. So as I said earlier, most of your work will be done sort of on the right-hand side here. So let's start with just adding in a stack column chart. I'll make it nice and big so that you guys can see. All right, so we've got basically a blank canvas here to work with. And we want to see how many tests were conducted by each agent. So at the bottom here, below all of your visualization options, you'll see that there is a x-axis, a y-axis. You've got your legend, small multiples, and tooltips. So if we want to see a responsible agent on our x-axis, it's really as simple as just dragging that over into your x-axis. But of course, we won't see any values at this point because we haven't defined anything yet for how many they've done. So in order to count how many tests each they've done, we're going to use cost of tests, obviously not the sum of. So, okay, so the first thing you'll see is we've got all of our agents at the bottom here. Sum of cost of tests. So that's not really the data that we're looking for, or it is the data that we're looking for, but it's not the calculation that we're looking for, because this is basically adding up the costs, the total cost for each one of our responsible agents over the duration of the time frame in which they conducted their tests. All right, so one of the nice things about the visualizations tool is that if you click the little drop-down menu on the side here, you've got a lot of different options for what it is that you want to see on your visualization. So in this case, we've selected sum, or it was actually auto-selected for us, so we're going to have to change that. But you can have the average, the minimum, maximums, count distinct values, so that would be to count unique values. But we're a bit more interested in just counting how many tests were conducted by this individual. So we can change the y-axis to that, which gives us the count of the number of tests by each one of the agents. So if you hover over each one of these, you'll see, okay, so if you have Vahola Watson, she did 84 tests, Laurie Miller did 83 tests, and then it sort of drops off a little bit as we move on. In our example, we also said, we want to rename this y-axis. So just for the sake of this, visual count of cost of test kind of sounds a little bit clumsy. So if you want to rename that, you simply right-click on it, and we say number of tests. And you'll see that it auto-updates your y-axis. I think responsible agent is perfectly fine and reasonable to leave as our label for the x-axis. Then the legend of the test. So the legend is the part that breaks down all of the individual responsible agents into what exactly the tests were that they did. So if we wanted to see that, we simply drag test ID into legend, and then we see that also gets automatically updated. I don't know about you guys, but this is a lot more intuitive and easy to use than, for example, using the graphs in Excel. This makes it a lot easier to simply drag and drop, play around with whatever it is that you want to see. You can see on by simply dragging and dropping your columns straight into your visualization pane here, and it immediately updates, which is really nice. There were some additional things that we wanted to add in here. So I just want to quickly go back to the slides. So we said select correct columns. Yes, we've done that. Title, change the title of the graph. I have not done that yet. Change aggregation method, use aggregation count instead of default sum. That we did. Because we were not interested in seeing the total cost. We wanted to see the total number of tests that they did. We've configured a legend. We'll move them around just now. Data labels, add to visual, that's important. And then for our tooltips, we want to add total duration of hours to the toolbox. All right, so let's get back to the graph. So let's see, what is the best to start with here? All right. So as you can see, if you hover over these, I hope that you guys are able to see it. We can see here that for this specific column in this chart, we've got responsible agent Kayla Turl. The test ID is PP0325. Number of tests for this specific test was 19. But if we wanted to display a bit more information in this black rectangle we've got here, this tooltips area is quite handy to do that. So let's add the duration of the test into tooltips. Let's rehover over that again. And we get sum of duration of test. So what does that mean? It means that Caleb Kenyon did 24 tests. It took him a total of 172 hours.
on test PPO 325. That's all that means. And for this, if we wanted to change the text in the tooltip, we can also rename that. Let's just say duration of test, because sum of also sounds a little bit clumsy. And you'll see that will automatically update. Duration of test, it automatically updates the description. So we have some additional instructions, and that was to do a little bit more with the formatting of this visualization. So if we go to format your visual, it also gives us a really wide array of different options for visualizations and to edit the look and feel of the graph, if I can call it that. So if we look at the top heading here, it says number of tests and duration of test hours by responsible agent and test ID. So these things are kind of all added in together as you're adding your data in. But once again, that doesn't really sound very to the point. So we can simply go to general, title, and we can edit that. Let's see. Let's call that number of tests per agent. Great, that's updated. And we want to align that in the center, just to give you an idea of the sort of visual control that you've got over that. And I think the instruction was also to position this in top center. All right, there we go. That's pretty much the first part of the visualizations. It's a very simple example, but it does give a nice sort of introduction into working with your visualizations, getting used to working with all of the different tools that you've got on the right-hand side. So you can flip between different graphs here. You've got a lot of different options, as I mentioned earlier. If you wanted to change to that, it's really just a matter of a click away. But of course, it's important to choose the most appropriate graph, so that when you do your analysis or you're making your data available, that it makes sense for the person that's reading it. Yeah. Okay. Hopefully you guys followed that. If not, you've got the opportunity now to try it out for yourself. So the first one, exercise first visualizations. It's a two-part sort of exercise that I'd like you guys to do. So the first part is connect to your Power BI desktop. Connect that first to your three tables. Don't just load in one table. Make sure that you load in all three, so that we don't have to go back to that a little bit later on. And then I want you guys to try and recreate these visuals down here. They're not too tricky to do. And if anyone needs any help, then you are welcome to, I'll be here for some questions, and I think so will Kate to guide those questions to me. We don't need to do it in breakout rooms or anything like that. Just try it for yourself, and yeah, if that makes sense.
15 minutes for this. So back, if you guys need to mute or turn on, so then back at 3 o'clock.
Yes, I'll be here, but
yeah, just we'll start up again at 3. Yep.
Okay. Is the visualizations clear? Can you see them properly? Okay. I saw one person nodding there, so I'm assuming that should be okay.
And everyone, let's, as we've done in the other sessions, once you've finished the exercise, please raise your hand so that we know that you're finished.
All right.
Sorry, I had a problem actually.
Yes.
The hours spent by test type, by test ID, and test ID. So basically, the test type is only available in the dimension table of the test, dim test. And when I add it, there is the empty one that I heard some people talking that they get this empty
Yes.
bar. So what was the solution for it?
So you have to use the test ID in fact tests.
All right.
Yeah. There is a deliberate sort of error in the data set, which we'll fix a little bit later with this dim test table, and that's why it appears empty. So it's actually quite nice that everyone's picked up on that. It's part of the Power Query part that we'll do later, and data cleansing and data transformation, where we actually have to fix that little error.
Gotcha. Thank you so much.
Okay, no worries. All right.
Sorry, there's one more question.
Yes.
Tiaan, can you please explain the use of small multiples, how and what to use that?
Yes. Just quickly have a look. I've not actually used the small multiples yet, but let's have a look. So I think it is a way that you can break down your charts into smaller divisions. So it's not going to make a lot of sense in this example here, but you can see the individual measurement IDs. Maybe we can try a different sort of things. Maybe we can try city as small multiples. Yeah, and then you can see, for example, the number of tests per agent, per city in which it was performed. It just gives you a bit more of a deeper look into your data set. Not the best example with these cities. Maybe we can try with countries. Yeah, then you can also see all your testers and what they did in each one of the countries, if we make use of small multiples. Okay. So just a small little wrap up about those the three graphs that we did now, and just visualizations in general. It's important to choose obviously the correct visualization type. You sort of always want to look at what you've got in your data set, and what is the most useful to display and get an understanding of your data. As you saw, sometimes data is not really suitable to be used in, for example, a pie chart, because you've got too many categories. And then something like a pie chart isn't that useful. You might want to use something like a bar chart, or for example, if you've got time series data that spans over longer periods of time, then you might want to make use of something like a time chart, or a line chart rather, in order to do that. Interactivity, this is something that we'll look at just now so far we've just made the graphs, but there's also some options within Power BI that we can make our visualizations a bit more interactive. And then of course data labels and formatting, and there were some questions on that, specifically how to display additional information regarding your data, such as totals or percentages on your charts. And for that, the entire section on visualizations and formatting gives us quite a bit of control over that. All right, so the next type of visualization I want to go through, it's quite a nice one. It's using maps and filled maps in Power BI. So I will click through that again just now. But some of the nice things about making use of maps instead of just our traditional charts, such as bar charts and pie charts, is that we can actually get a geographical representation of our data set, but actually on a map, so that we can get a better idea of where things are happening, but also how things are relating to one another in a geographical context. So you can perhaps think of, if we had to use an example of for example, sales, we could have different areas in where there might be more or less sales. In terms of the example that we've got here, we could perhaps see if there is areas where the air quality is particularly bad or where the air quality is particularly good. And then also perhaps why the air quality differs across different regions. So that's a really nice practical way to have a look at our data by making use of maps. Then an important thing as well is drill through and filtering and granularity. I'll get into those topics as well when I explain the demo. But basically, if you think about our data set, we've got a country and we've got a city. And so that tells me immediately that there might be some hierarchy between those 2 points, and that we can evaluate the data not only from a country perspective, but also from a city perspective. So once we go one level lower than country, we get to the city level, and we could perhaps also have a lower level than that if we had on a municipal level, for example. So that's something which is also important to, not important, but yeah, it's nice to keep in mind when you're making use of maps and visuals, is that we can analyze our data from different perspectives. It need not only be from a country level or from a city level. It can also be across on different dimensions. So also, if you kind of think about yes.
I think that's an accident. Let me mute that again. Sorry, go ahead.
No worries. So you can also think about the levels of analysis that you can do. For example, if you were looking at a certain period of time, you can look at things on an annual perspective. You can look at things on quarters, so every 3 months. You can look at things on a month level, on a day level, on an hour level even. But the same idea, the same kind of thinking applies when it comes to drill through and filtering and granularity, as you see it on the slide there. It's all about configuring our graphs in such a way that we can get to different levels of depth in our analysis. So some use cases is kind of, I suppose, intuitive, the different kind of use cases in which you'd want to use maps to visually represent your data. An important part here, it's good to remember, and it's something I touched on a little bit earlier in the Excel sheet. There are certain requirements that need to be in place before you can make use of the maps and filled visuals in Power BI. So you need to have geographic data points in order to make use of this specific type of analysis and visualization. So you might think that, okay, is that always obtainable? Well, there's always ways that we can get points like latitude and longitudes. I know that there are now in for example, software packages like Python, there are libraries that you can make use of that would give you the latitudes and longitudes from pretty much any point in the world that you want. So even if you don't have that data in a data set, I think as a data scientist or data engineer, that's like a nice additional thing that you could perhaps do to make your data set a bit more valuable for your clients or for your stakeholders, if you can call it that, is that you can actually go ahead and use some tools to give yourself some latitudes and longitudes and locational points, and then you can really take your analysis and your reporting to a whole nother level, which is really nice. Okay, so I think it's probably best to go ahead with the demo. Then you guys can get a good idea of that. I'm not going to click through all of the maps there. We don't have that much time, so I'm rather just going to show it how to do it. Just make sure that I open up the correct. Okay, it's not that one. It's this one. Okay, so in the Power BI slides, or on the PowerPoint slides, pointed to these two maps there. You've got just a normal map, which will give you sort of give you the bubbles or little circles on your locations where certain events have occurred, or where something of interest has happened, something that we want to analyze. And then we've got the full map, which gives a more broader regional look at things, and I'll demonstrate both of those. So first thing is open up the map. I'll make it nice and big. And right now, obviously, we're just sitting with an empty map here. Okay, so that's our map. And now an important thing here, and I suppose, yeah, it's good to place emphasis on the importance of this, because it's got to do with the level of analysis that we want to look at. As I mentioned earlier, we can look at our data from different perspectives. We can look at it on a country level. We can also look at it from a city level. So within our data set, there are always things such as hierarchies present. Whether you have dates, there would be hierarchies. For example, a year is bigger than a month is bigger than a day. And in our case here, the hierarchy that we're going to be using is simply a geographical hierarchy, which is our country and our city. So Power BI is not going to automatically estimate that. That is something which we're going to have to put in ourselves. So I'm actually going to close fact test and dim test for now, and we'll just focus on dimension report for now. So we briefly looked at that in the Excel sheet. We've got some columns here, some latitudes, some longitudes, and we've got our cities and our countries. So what we want to do now is we want to create a hierarchy between our countries and our cities. And this, if you're going to be using Power BI in the future, this is something which you're going to be using fairly often, is to actually create hierarchies in your data set. So let's go with in some previous versions of Power BI, you could always just drag your columns around and you could place them in the hierarchies. But with the latest versions of Power BI, you need to actually right-click on your highest level of your hierarchy, so country, and we go create hierarchy. So it creates country hierarchy, but I think for us, it's maybe better to rename that to, let's just call it geography. All right, so let's open up that hierarchy. And we can see at this point, we've only got country in it, so not much of a hierarchy at this point. So what's one level below our country? It's going to be city. So let's add that to hierarchy. It'll give you a drop-down menu of all of your different hierarchies. For us, we've only got one at this point, and we can add that in. And the importance of this I will demo just now. So we've got this geographical hierarchy inside of our dimension report. So that's really the only change we had to make in order to start populating our map here. So let's take geography and drag it into location. Kind of makes sense as well that geography would go with location, and we immediately sort of are popped up with a map. Doesn't tell us much at this point. So I actually want to use geography also as my legend. If I do that, then we can see, all right, there's all of our different countries where all of the tests were done, and they are and they've all got their own separate colors. Then we're going to use the latitude and longitude also. Power BI gives us the availability of that. I don't know if anyone would actually like to answer this, but why do you guys think we need to make use of things like latitude and longitudes and not only city names or anything like that, or town names or regional names or anything like that? Why do you guys think it's important to make use of latitudes and longitudes? Does anyone want to have a go at that?
The city names are presented as polygons on the map, whereas the latitude, longitude are presented as points on the map. So it will give you the exact location.
That's right. There's one more sort of critical point. All right. So if you think about cities in Germany, cities in France, cities in England, you might also have the situation where you have these cities in other countries as well. I know that happens quite a lot in America. A lot of the places are named after European cities, and also in South Africa, a lot of the places are named after places in the Netherlands, places in France, places in Germany. So if you only to use your cities or your towns or anything like that, you run into the possibility that you might be making points available on your map which really have nothing to do with your data set. So when we make use of these maps, it's always good, or you always have to use your latitudes and longitudes to make sure that you've got everything at the correct place. Okay, then, so we've now got these, we've got our points here, and then important here at the top, we have the option to click to turn on drill down. So that's important. Why is that important? So at this point, we can only click on the different countries, but we know already by now that there are lots of other data points as well, like we specified in our latitudes and longitudes. So this is a very important function up here, the drill down function. Once you click on that to make it available, and we click on Germany, we can see, all right, there are all the areas in which tests were conducted by our different agents. So that's quite a nice and neat, easy function as well to have access to that. So if you go here, we'll see country Germany, Cologne, average latitude, average longitude, and we've got all of the places in which some sort of a test was conducted. At this point, we don't really have any other information than that, other than just the that there's something happened at these places, but we don't really have any other additional information at that point yet. So what we can then do is whatever you're interested in knowing, and for this example, I'm going to make use of, for example, air quality index. I'm going to drag that into bubble size. And okay, sum of air quality index is probably not the best to use. We'd rather want to use the average of the air quality index. We can see that it's fairly similar all across Europe here. If you hover over your tooltips, however, you'll see that, for example, in Norway, the average air quality index is 71.46. In Denmark, it's 68.21. Germany, 66.33. and in Switzerland have 68.53. We have the drill mode on, which means we can actually go one level lower. So let's do that with France. Zoom in a bit. And we can actually have a bit of a better idea of, in these regional areas, what the air quality index is. So we can see that here we have a fairly low air quality index of 30. And you can do some of the playing around to see, and you can add multiple bubble sizes, multiple different information points into tooltips. So you can also, for example, let's see if this will work, tooltips. So if we click on that point, we can see that the average of the air quality index was 60.40, and the air quality is good. It's considered to be good there. So we've got all of our data. There's a lot of things that we can add in here to give us more information on the different areas that we've conducted our tests. And you can imagine for yourself in which ways this can also be very useful. I mean, just as recently as a year or 3 ago, during the coronavirus, for example, this could be a very useful tool to indicate where there are big outbreaks of cases, or where there isn't big risks. We can use it for really in sales data, in business, to get a geographical understanding of what is happening with our underlying data set. All right. Then there is the other graph that we can also make use of, which is the filled map. And for this one, we can use exactly the same. You'll see that we've got location, legend, latitude, longitude, so no different to the other one. Let's add in our hierarchy, location, legend, and you'll see that this will give us sometimes it takes a bit of time to actually populate. I don't know why. It's sometimes a little bit more slow to update. Let's add our latitudes, our longitudes. It takes a bit of time to update. There we go, Norway is updated. And for this, we can also, once again, we can add, or we can put on our drill mode, and that gives us access to lower levels in the data. We have to zoom in a bit for that. But if you zoom in, you can sort of get a more regional look where tests were conducted. Now, with this one, you won't see any bubble size because the regions don't really change when you it really just gives us ability to look at where something has happened, and then we can use the tooltip function in order to provide ourselves with some additional information. So, for example, in this one, let's use air pollution penalties. Zoom in a bit. So in the area of, I'm not going to even try to pronounce a French name here, but in that city, at that longitude, we've got air pollution penalties called mid-level. You might want to fix that a bit later. In Marseille, air pollution penalties are considered to be high. In Monaco, or actually that's Nice in France, air pollution penalties are high. So maybe we want to see, all right, what can we do with that? What does air quality tell us? Is there perhaps some sort of a relation we can see in these areas where if we've got low air pollution penalties, air quality is perhaps poor. Mid-level air pollution penalties, air quality will be medium. And for example, the same thing. So we can add in a lot of different columns in our that we've got available in our data set to give us some regional information, which is quite nice. All right. let's quickly have a look. Let's go back up. So that's quite nice. That's these are two visualizations which are really nice to work with. Quite a bit of fun. Well, at least I find them to be quite fun to work with. And yeah, that is pretty much it for the demo. For that, we'll get back to this one just now. And we've demoed this. All right. So this is another exercise that I want you guys to do. The map creation one. So I want you guys to try and recreate. It doesn't have to be, you guys are welcome to use, for your bubble size, feel free to use whatever statistic you're curious with. So it doesn't have to be strictly my one, but select a map. Very important, critical to do is create your hierarchy. You remember you can do that in the right-hand side. You have to insert your location and legend with hierarchy, insert your latitudes and your longitudes, and then just play around a little bit and see what you want to include on your bubble size to give you. So you could perhaps choose the maximum air quality index or the maximum cost. Or you can just use my one. Feel free to do whichever one you find the most interesting. And I'll be here for questions. All right, back again. All right, so up until now, we've had a look at some visualization options in Power BI. And I mentioned a little bit earlier on, and it was actually, some of you picked up some little errors in the data set. I will upload after this. I'll upload what I call the corrected data set, which will be some of the changes which we're going to be doing now, but in Excel format for those perhaps who didn't get to follow all of the exercises. But the next part is sort of I'd like to sort of think about it as the underlying back end of Power BI, and that's called Power Query. And Power Query in a nutshell is the sort of the scripting language that allows us to connect to and read in all of our tables, our DIM report, our DIM test, and our fact tests. And we're able to make some changes to our data set. It'll always keep our Excel sheet the same, but it'll change the data set that we have available to us in Power BI desktop. So a little bit about Power Query. We did mention that in one of the opening slides as well in our ribbon. If we want to access Power BI or Power Query, you do that via the transform data icon in your ribbon. I'll go through that just now. And I'm just going to click through all of these. And like I mentioned, some of the things that Power Query is really useful at is firstly data transformation. And I suppose that we can add to data transformation also data cleansing. We can also, as part of our data transformation, we can make use of things such as parameters to change columns or to add additional columns and really take a raw data set like we've got now and pretty much change it into any way that we'd like to. It supports data source connectivity. So we went through the get data function where we've got a wide sort of array of different sources that it can connect to. And Power Query is what makes that getting and loading of data possible. Data mashup, it allows us to combine, for example, DIM report, DIM test, and fact test together in queries if we wanted to do that. And like mentioned, it supports data loading and data refreshing. So we have a static data set. So our data set isn't going to change between now and 2 hours time. but sometimes you will make use of a little bit more of a dynamic data set. For example, when you are creating Power BI dashboards by making use of an SQL database. And in that case, you might have to do some configuration that allows you to refresh your dashboard so that your dashboards are always up to date with the latest information, or at least what is within the requirements of your organization. And I'll show an example of applied steps and repeatability just now, because Power Query is based on a coding language. We can repeat the steps that we make use of in our data transformation, not only at the data loading phase, but whenever it is that we need to redo any sort of transformation or any type of loading. All right, we have an overview of our queries here, and I wonder if it's not perhaps better to just display or actually show it on the, because this doesn't read as well as we earlier found out. So I think I'm actually going to just use I'm going to use my actual Power BI desktop to go through all of it. All right, so like we said, to access Power Query, let's just open this so that it doesn't distract. So we access Power Query by going to transform data. All right, let's open that. It opens it on a different screen. And that gives us a sort of overview of our data. And we see 3 queries. And it's not really labeled as 3 tables, because from a Power Query perspective, these aren't really tables, but they're rather queries which it's based on the M language. It queries the Excel sheet and it pulls the data into Power BI, but it's not a table that's actually present in Power BI. It's more that we use Power Query to call the table. So we've got our 3 queries here. So you can sort of think about it. The moment you clicked on dim report, dim test, and fact test, at your original phase where you clicked on get data, there were automatic queries that were executed that pulls the data in. So I'll give an example of what I mean by this. So let's look at the simplest table here, dim test. That's there's not too much going on this table. If you click on advanced editor, this is actually what's happening in the back end. You can see there the source, excel.workbook, and that comes from my PC, but it's actually that air quality Europe.xlsx XLSX file. So Power Query is a language that reads in the data for us. So what's useful about this is that we are able to make fixes, changes, we can clean our data, and it's always going to be stored as part of an applied step on the right-hand side here. So we could actually, if you click on the steps, you can actually see the steps that Power Query went through to get this table. And once we actually do some of the changes, it'll be a little bit more intuitive to understand how these applied steps work. Let me just go back to the slide so that I can see what we have to do next. All right, so we have our 3 queries. And once again, we have a ribbon with predefined functions. We have our applied steps, and we have the output of the selected step. And I'll show just now how those change depending on what step we're actually in our Power Query. Just a quick overview of the ribbons here. We have a remove columns, remove duplicates functions. we've got basic transformation operations. So depending on the column that we're using, and we're going to use this just now, we can find and replace values. We can do some formatting on the columns. This is useful for fixing errors in our data set, maybe replacing empty values, or values which we want to represent in a different way can be done quite nicely using this transformation tab. We can create operations and queries. And also some more formatting options is to, for example, detect what kind of data type it is in your column. We can fill, for example, none values. Yeah, just lots of different options. Text column operations such as first characters and lowercase. So if we want to change an entire, and sometimes that is something that we want to do, is to change an entire column to lowercase or to uppercase or something like that. And then some operations such as rounding, which can sometimes be useful as well. And then date and time column operations, which we'll get into just now. All right, we've also got the option to add some custom columns. We can also add in conditional columns. So what's useful about that is, I don't know if perhaps some of you have used in Excel things such as VLOOKUP tables or things like that. Power Query provides us with an easy interface where we can add, for example, a conditional column. So if one of the column values is X, we can output Y on another column. We can create index columns. So that is if we just wanted to number a column from 1 to 10 or from 1 to 20, which is sometimes if you're doing queries and mergers and joins, that can sometimes be handy to do. And then this is the same as the other tab where we can do rounding and scientific notation or whatever it is that we need to do. All right, like I said, all the steps are stored. Steps can be removed in between if unnecessary. We can have a look at that just now as well. And I quickly went over that each step in this user interface is actually a little script, and it's based on the M language. Okay, so to get into the demo of these things, I just got to quickly see, we'll just remove redundant, transform values. Okay, we can always come back to those. Okay, so in our Power Query overview, we want to make some fixes and changes to the data set. Now, I don't know if you guys noticed a little bit earlier on, but in our not in our data pane under the report view, we had a column 10. Now, it perhaps doesn't cause any damage, but column 10 really doesn't add any particular value to our data set. As you can see, it's just a null column. And so that's just in good practice. It's pointless to have this column around. It could be a little bit confusing if you see this column 10 with all the null values. So the best thing to do is to simply remove that column. So you can go into your ribbon at the top there, and you can simply remove it. Now, as we mentioned earlier on, all of your steps that you execute in Power Query are saved in your applied steps. So you can see there that we have removed column. If I delete this step, the column remains. It's still there. So we obviously want to delete that, remove columns. And if you go back, for example, to the previous step here, you can actually still see the column. So you can exactly see what has happened. So perhaps you do, a combination of 10 to 15 different data cleaning steps, and you'd like to look at what you've done again, or perhaps there's some things that you don't want to do anymore. You can simply delete it from your applied steps. So that's quite nice. Another instruction on the slides had to do with air pollution penalties. So we've got high, we've got low, we've got mid-level, and sometimes the hyphenated level, it's really not valuable additional information. It's also not really in line with how everything else is named. So perhaps we want to remove that. So for this one, we want to use the replace values. So what we actually want is we want high, we want mid, and we want low. So if we click on replace values, we can say value to find. We can say level. We don't really want to replace that with anything. We click on that, and it fixes that entire column for us. So once again, you can see that on the right-hand side here, these steps are recorded for us. So that's quite nice. I think one of the other instructions, if I remember correctly, was that we don't want these to be uppercase. We want all of these to be lowercase values. So for that, you've got the option to go to formatting, lowercase, uppercase, capitalize each word. And we're going to change these all to lowercase. Now, I don't quite remember what was the other ones. Let's see. Remove redundant column in dim report, transform values in air pollution penalties to lowercase and remove levels, rename column name cost per hour into max allowed cost. All right. All right, so we want to rename this column over here. We don't want it to be cost per hour. We actually want it to be max allowed cost, because we actually already have the cost for every single test recorded in fact test. So this would be considered quite a big change, but we can rename this. Where is the rename? We want that to be max allowed cost, which also makes more sense in the data set, because it's very difficult to have one cost for every test if it has to be conducted all over Europe. The next one was, and this is actually where a lot of you picked up the error, if you had used dim test as part of your charts, you might have found that there was no values, and that has got to do with that there is a relationship between test ID and if you go to fact test ID. So you can see that there is a difference between these. So that relationship specifically with regarding to particle pollution, there's going to be a mismatch there, and that's why you would have gotten no values there. So for this one, we also want to do replace values. So we want to replace PP 0 to 0. We want to just replace with PP 0. If that is correct. PP 325, PP, yeah, I think it is. If it's not, we can always come back and change it later. And then another change that we wanted to make here is to change NDO 325, because that also doesn't really fit with our data convention that we've got here. We want it all to be capitals, so we change that as well. And you can see that it's still continuing to record all of the different steps per query. We've actually, we've enhanced our queries now to do some data cleaning. And what was the last one? All right. Fact tests. So for the last one, we actually want to do a bit more of a calculated change to this column, or to this table rather. And for that, we're going to go to add column. So what's the instruction? It says add column cost per hour. Don't worry about the rest yet. So cost per hour. So if we want to work out the cost per hour of a specific test, that could be a pretty useful statistic, because it would allow us to get a lot more insights as to perhaps how much each of the responsible agents have cost us regarding these tests, or how much has a specific test cost us. So it's quite a useful one to add. So we can add a nice feature here by actually finding out, okay, we've got the duration of the test, we've got the cost of the test. So we can actually add a column here. Let's call that, or let's go to custom column, left-hand side. We're going to call that cost per hour. And we're going to denote that by PQ. And the reason we are denoting that by PQ is just to keep in mind that we did this column, we added this column using Power Query, which is when we do the comparisons later on, it's just useful to know where we did that. So what's the custom column formula? Well, we want to take the cost of the test. It's quite nice. It simply brings it up for you, cost of the test. And we want to divide that by duration of test in hours. There we go. It pops it up, it prompts it up, which is quite nice. Let's click OK. And there we go. We've got cost per hour. So all I did was using that query, and you guys will get a chance to do this as well. Take the cost of the test, divide it by the duration of the test, and that gives us a nice little extra bit of information in our column, which we did all with Power Query, which tells us how much it costs per test per hour for this specific measurement ID. Now this column doesn't look great at the moment. We've got a lot of decimals here, so we can use the rounding. And perhaps for something like cost per hour, we only want to round to, for example, 2 decimal places. Whoops. Sorry, remove this one. That's not correct. First thing I actually have to do here is I need to change the data type. So if you have a look at the top of all your columns here, you have a little ABC there, you've got a 1, 2, 3, and that gives you some control over the data type. So at this point, ABC 1 to 3, Power BI doesn't really know what kind of data type this is. So for this, we're going to change this to a decimal number, and then we'll change the rounding. Round to 2. Sure why this is only supposed to only give me that one, but that's okay. Let's see if I remove that column and then just rename this one. Cost per hour. All right, great. I think that was all of the transformations that we wanted to do. And if we're happy with all of the steps and we're happy with all of our changes that we've made, simply click close and apply. And then that should be fixed. So if we go into our table view now, you'll see that the redundant column is gone. If we click on dim test, we'll see it's max allowed cost. We go to fact test, we can see our cost per hour is factored in there. Also, we have fixed now the under dim test, we've also fixed PPO 325 and NDO 325. So those are a couple of pretty quick examples of what you can do with Power Query. And it's quite an important part of Power BI, especially for changing data sets, cleaning data sets, making transformations before you want to perhaps do your analysis. And it's also an exercise for you guys to do, is to do exactly the same ones that I just did now. So I'll leave all the instructions on here. If you guys have any questions on this, which I suspect there might be some questions, because there was quite a few intricate little points that we covered now. Yeah, feel free to ask, and then I'll hopefully be able to answer the questions. Also, just while you guys are busy now with an exercise, I have uploaded these slides are also available on GitHub. If you guys would like to access them afterwards to perhaps play around more with Power BI or just sort of refresh whatever we've covered in the session. So these are available on GitHub. There's also a note at the bottom here. In file Air Quality Europe corrected XLSX, these changes have been made. So that's also something I'll make available afterwards, but I didn't want to upload both of them because then you might think that might lead to some confusion if we had two data sets with one that's corrected, but I'll upload that to GitHub afterwards as well. Okay. Let me just quickly get my bearings here. I've got a lot of things open on my PC here. The next thing, or next topic, it was also something which we briefly touched on a little bit earlier. We said we'll get to it a bit later. And that is all about making your reports, your dashboards, a little bit more interactive, where the user can, for example, make some selections and sort of get their own idea of the data depending on what it is they want to see. So there are two nice features in Power BI that makes this available or makes this very easy for us as dashboard creators. And the first one is that of filters. So with filters, you can pretty much create custom conditions on a graphic level of what it is that you want to see. So that was this filter columns that we've got in our report view. So you can actually see that when we haven't done anything custom ourselves, there are automatic filters. So for example, country is all. That just means that we are looking at all the countries. We're not saying country is Austria. For example, if we had to say something like country is Austria, then on that specific graphic, we would only see data that relates to Austria. Or perhaps we'd want to configure something like we only want to see data related to a specific tester, a specific measurement agent, responsible agent. And we can do those using filters, and those filters will then stick to that graphic. And we'll do a demo of that just now. And then another nice one is actually something that you can find in your visualizations pane. These are called slices. It's this little function here, this little graphic here. And it basically works similar to a column header filter, something which you might have used before in Excel, for example, where you specify a filter and then you can filter and slice your data and get a more detailed view of a specific agent, a specific country, or a specific test. Also a really nice function to work with. An important thing, and we'll demo this as well, is the interactions. So you can sort of think like if we have a slicer on a dashboard, the automatic and default position of that slicer is to slice all of your graphs. So it's going to, if you select, for example, France, and you've got 5 different visualizations, it's going to take France and use that as a reference point for all of your charts. So it's important to configure your interactions only to what you want to visualize. And that might be a little bit easier to demo, but just good to keep in mind for now. So you've got basically 3 different types of interactions. You've got filters, slices, and then it's just important to keep in mind the interactions for these filters. All right. So rather than rather than clicking through, I'm going to rather demo this for you guys. So I hope that you guys have all kept your 3 charts that we made right in the beginning. So we had I think it was a pie chart, we had the tree map, and we had the column chart. So hopefully you guys kept all of those, because they're going to be a little bit necessary for the next part. If you haven't, it's also not a train smash. You can quickly make a graph when you do the exercise. All right, so we've got, so what I did was, when we did our first visualization, exercise after the first visualization, we all made these three charts. And we want to add if we want to add a filter to them. So let's just quickly see what was the condition for the filters here. Let me just quickly see. Add slicer on responsible agent for all graphs. All right, great. So we'll start with the slicer. So that was this little icon here. We add that in, and this one's quite a nice simple one as well. You've only got one field here. We put in responsible agent, and it immediately populates your list with all of the different testers that we've got. So you can kind of see immediately where this is going to come in handy. So instead of looking at things on a big column chart where you've got all of the different agents, you can now really zoom in on each one of the responsible agents to get a really good idea of what this guy or what they have been doing over the past few years as a responsible agent in testing air quality. So, like I mentioned, and actually there's something I want to I hope I don't mute myself now. I want to take this off because we need to, it's part of the demo. So the thing I mentioned is that if you click on one of the responsible agents, the automatic default position of Power BI in this case is that it's going to apply your slicer to all 3 of these charts, and that's not, sometimes it's desirable behavior, but not always. So if we click on just Aaron Bootman here, we can see the count of cost by country. So that heading is not great, but it's okay, we can rename that. So Aaron Bootman, he did 2 tests in Italy, 2 tests in Spain, 2 tests in the United Kingdom, 1 in Sweden, 1 in the Netherlands, 1 in Germany. He has spent 25 hours doing the particle pollution test. He spent 16 hours doing the nitrogen dioxide test. And then we can also see a breakdown of his costs as he's conducted his tests. So that's something which is quite useful. Now, something in the demo, it says apply this to all of the graphs, but it might be handy to just quickly go to this. So under this, I don't know if you guys can see the zoom toolbar here. Hopefully you can see that this is format. It says format there. And there is a little icon on the left-hand side here. It's called Edit Interactions. And what you'll see is, as soon as I click this, it brings up 2 little icons, one that says filter and the other one says none. And in this way, we can control what we want each one of our graphs to be able to filter. So let's just, as a demo for now, we click on Aaron and we can see that, okay, right now all of our graphs are changing as we click them. So I think something which is quite useful, just from my own perspective, is this is quite nice to see on an individual level. I think also the duration that they spend per test, I think that's quite a nice thing. But I didn't gain that much value yet from this one. Maybe you guys did, but it's personal preference. So if I want to change this now, we keep this one on filter, we keep that one on filter. We say, no, we don't actually want to filter this one. So now what we want to see is this remains static as we toggle through our different responsible agents, and the other graphs should change. So we can get, for these two, the individual level, and for this, we still get for the entire organization. Let's see, hopefully that works. All right, you guys can see that that sort of works. It's also nice that you can click on multiple agents. So for these four, we can see that these also change. So if you want to click multiple agents at the same time, you need to go control click. That's just from a user point of view. So yeah, that's quite an important one to remember is insert your filter. The default position is that your slicer will affect all of the different all of your different graphs. And that depends on your requirements, what it is that you actually want, whether you'd like it to do that or not. But either way, pretty easy to control, format, edit into actions, and then you can change that. I believe the next point, if I just quickly check on my slides here, was to add a filter on the tree map graph on test ID CM0325. All right, so let's say on this one, I see that I've already actually done that, which is not ideal. So let's take that off. All right. So if we wanted to say we want to add a filter to this graph, and we only want to display tests relating to CM0325. Drag your test ID onto that visual. Select CM0325. And now we can see that Aaron Bootman did 2 tests of CM0325 in this country. So it actually might be better to rename that as well. I think that was also one of the instructions. Go to general, title. Let's just change that to number of CM0325 by country. And that makes it a little bit more clear. All right. Yeah, so that's a nice way that you can have some control and interactivity on your visualizations. I think I do have an exercise for you guys to do this one as well. Let's have a look. Yes. All right. So make sure that you have at least 3 graphs, and hopefully you guys do have those 3 graphs that we made in the first visualization. I want you guys to add a slicer to your dashboard from the previous exercise, and for the slicer, just use the responsible agent. Add a filter to your dashboard from the previous exercise, so add that in. And I think the one we used was the test type, and make that one also specific to your filter tree or your tree map, and then play a little bit around with the changing of interactions. So possible scenarios: if you've got 3 graphs, graph 1 filters graph 2 and 3, graph 2 does not interact with graph 1 and 3. You guys can play around with that. Just make sure that your intention is also what you see back on your interaction, if that makes any sense. That if you want one graph to not impact the other graph, or one slicer not to impact the other slicer, that is what you end up with. If that's not the case, yeah, let me know, and then I'll answer the question.
Great. There are some questions in the chat I wanted to save to the end, so less interruption. Okay. Alma asks, do we visualize in the same page or on all pages?
Just visualize on one page. So, for example, if you've got, just create a new page like that. So from your first exercise, you would have had these 3 graphs here. You can just Control C. You can do it on there, or you can just copy it and paste it to another one if you would like to keep your first exercise exactly in the way that we did it. And then you can
then you can add the slicer here. This slicer is not going to impact any of the other graphs on these pages here. It's only going to impact on this dashboard here. So it doesn't reach beyond this specific page. It'll only stick to this page. Hopefully that answers the question.
Yep. Shivam asks, what exactly is the difference between filter and slicer?
So a filter, let's say that you make, let's use an example. So let's say that you've developed you've made a dashboard and you've embedded it in a website somewhere. If you've implemented a filter on your visualization, there's no one that can edit that, no one can touch that. People won't even know that it exists. You, as the dashboard creator, it's something for you to add in. If you use a slicer, you're providing control to the user, that they can have a look at, or they can make some changes to the data set. So the one is dynamic. Also, it's got a lot more options, whereas the filter is sort of if you want to call it, a hard-coded restriction on what is being made available on your graph.
There was a bit of questions around one of the steps. There's a bit of a thread. Hold on, I'm just reading through it.
All right.
Zoe asks, Aaron Bootman went to a different country in my data set, or did I do something wrong? A couple of people had this happen. So they're wondering maybe if they used a different data set or if their changes were not correct.
Okay, let's see. So they said Aaron Bootman went to a different country. Okay, let's see. So firstly, let's see what we've got on here. So
sorry, can I just quickly interrupt?
Yes.
Sorry, I just realized what the problem was. I think we forgot to add the filter, and
Yes,
once we add the filter, we'll get the same values that you did.
Yes, I think that's spot on. I think that was probably why you might have seen something a little bit.
Yeah, I
different.
think so. They're also agreeing in the chat.
Awesome, great.
Thank you.
No worries. All right. Next, and pretty much the last section is, I mean, I think it's probably also good. So we just sort of recap quickly where we are, what we've done, just also from my own head. So we've done some basic visualizations. We've had a look at some of the maps. We've had a look at some of the slices. We've gotten into some of the Power Query. And really the last part of this, I suppose, falls a bit under data modeling, which are measures versus calculated columns. So we've already done actually a calculated column. You would remember that we did that in Power Query, where we did the cost divided by the duration, and we denoted that with PQ because we actually did that in Power Query. We most likely will do the same one again now, but we're going to approach it not from Power Query, but from outside of Power Query, so within just the report view, and so get the difference between what is a measure and what is a calculated column. So measures and calculated columns are both calculations that we do using a DAX formula. And that is a data analysis expression. So I think if all of you did followed through the Power Query steps, you would remember that when we did the calculated column, so when we calculated the cost per hour for our test, we sort of wrote a little formula for that. It was cost. We had to name the column, and then we said this column divided by that column. And that's really a DAX formula. So both measures and calculated columns from a Power BI perspective are actually at the back end just done using data analysis expressions. So measures are used more for context-aware calculations and interactions. I'll explain that with the use of an example just now. Lots of calculated columns for row-level operations can also be performed via Power Query. We're going to do it not from Power Query, but from the report view itself. This is maybe interesting to remember, is that the calculator symbol indicates a measure. A table with a sigma sign includes a calculated, or it shows a calculated column. So that just refers to these two differences here. And let's take the above and rather look at these two examples. Can you guys see this? Can I actually zoom a little bit on this? Yeah, I can. That's nice. So if we do a calculated column, you'll see this sort of looks similar to what we did in Power Query. We name the column and we say from the table fact tests, column cost of test, divide that by fact tests, which is our table, and duration of test. In ours, that's really the similar thing that we did in Power Query. And what we're doing in essence is we're taking every single entry on a row level and we're performing that calculation, and we end up with a new column that gives us the cost for that specific row entry. Let me just go back. If we do a measure, we don't calculate it on a row level. We actually, it depends on, and that's where it gets a little bit more useful, but also a little bit more tricky to conceptually explain the difference between a measure and a calculated column, because a measure depends on from what level you're actually looking at the calculation from. But the biggest difference between the two is that with a calculated column, you're creating an additional column which contains on a row level the calculation as expressed in your DAX formula here. So your cost per row is your calculation that you've got here. But on a measure, the cost per hour depends on whether you're looking at the entire table, or perhaps we're looking at just for Aaron Bootman, for example, if we're just to use an example of the previous one, or are we just looking at the country of France to find out the cost per hour? It depends. So with the calculated column, if we go back to our data view, we actually see an entire new column that's been created. But with a measure, you don't actually see anything else. It's simply calculated on the fly whenever you need to look at the cost per hour for your question. I'm getting a little message here. My internet connection is unstable. Can you guys all still hear me fine? Okay.
Yeah, we can.
All right. So just as to compare the two, and don't worry if it's not 100% clear yet. We're gonna do this one as an example as well. But some of the differences: dynamic calculations that responds to users, measures do that, calculated columns don't. So that's kind of intuitive as well. Our calculated column our cost per hour calculated column is going to exist in the back end regardless of what we're doing on the front. Whether you're using your slices, whether you're using your filters, that column remains at the back end there, regardless of what you as a user or you as a developer do. The dynamic the measure only is calculated when you actually interact with your dashboard. So there's no column at the back of it. It's simply a calculation that is called every single time you make use of it as part of a slicer, or if you're calculating it just as a total, but there's no underlying column that exists for it. It is a calculation that you configure, but there's no underlying infrastructure or resources used. And that's probably a good segue into the next part here. Consumes memory and storage space in data model interactions. So measures don't do that.
because they don't exist until you actually do something with them. Whereas the calculated column, if we go to our table view in Power BI, you'll see the calculated column there, suitable for aggregations and context-aware calculations. So that ties in with the dynamic calculations that responds to the user. So measures are context-aware, whereas calculated columns are not, regardless, once again, of what context you're looking at, whether you're drilling up or drilling down. Your calculated column will still exist, whereas your measurement changes depending on what level you're looking at calculation from. Negative impact on data model performance. Measures shouldn't do that. Calculated columns, maybe. It depends on the size of the data and the resources that you've got available. Computed on the fly at query and visualization time. Measures, yes. Calculated columns, no. Computed during data model refresh. Measures, no. And calculated columns, yes. So that actually ties in quite nicely with a question that was asked earlier through in the course. What happens when we refresh our data? So we had those applied steps in Power Query. Those will remain, and therefore your calculated column will also remain, but your measure will not, because the measurement only exists at the time that you're actually interacting with it. Used for row level calculations and creating new static columns. Of course, measures not, calculated columns, yes. All right, so let's get into a demo, because it's a little bit of theory there, but it's probably better to look at a demo. So add column, cost per hour via Power Query to table, if not done already. So that's something that we've done already. We've added that in already. But we're going to add exactly the same one, but from a little bit of a different area in Power BI. Let me just make sure that I've got the right stuff open here. No, I don't want to use this one. I want to use this one. No, this one I've created already. So, okay. So let's go to fact tests. So once I click on fact tests, is this the correct table to add it to? I believe it is. Yes, it contains our cost of tests and our cost per hour. So our cost per hour here, that is the column that we added in using Power Query a little bit earlier on. We said, okay, cool, we want to do a little bit of feature engineering on it, and we want to add a little bit of extra information. But you can also do that if you click on your fact test table. You get a little ribbon up top here, and you can see these calculations are grouped together. You've got new column and you've got new measure. So those two differences there. So if we click on new column, it opens up what prompts us to enter a little formula here. So this over here is what we call our DAX expression, our data analysis expression. So let's do that, cost per hour. And we're going to say that's a calculated column. We haven't done it from Power Query as with this one, just to distinguish between those two. And that is coming from fact tests, right? We're on fact tests, and that is cost of test. And we're going to divide that by duration of test. Okay, so we've created that. We can see the little sign also there that it's a calculated column, the little image there. And if you go to your table view now, we can see we've got cost per hour created using Power Query. We've got cost per hour that we did using created column. So that's that additional column. So if you think about the comparison table that we did a little bit earlier on, we've now actually gone and created an entire additional component to this data set. We've added another column. And of course, if we're working with small data sets, such as this one, it probably is not going to make any critical difference to my machine, but If you're looking at much larger data tables, or within SQL tables where you're looking at millions and millions of rows, adding a additional column, I'm also not trying to paint it in it's a wrong way to do things or it's a right way to do things. It's a different way of doing things, but it's something to keep in mind that when you're adding an additional column, it does have an impact, however small or however big. It will have some impact on the resources that your machine is using. All right. And the next one is to add in the measurement. So with a measurement, let's say cost per hour. Cost per hour. It's also a DAX expression. We're going to say sum of fact tests, and that will be the cost of the test divided by the sum of duration of the test. Oops. I need to quickly just check what the correct way is for that. There's some cost of test, some fact test cost. Yeah, I'm just going to copy that one. The brackets aren't great. All right. So we have we've calculated the cost per hour, but we've calculated in a little bit of a different way. So the big difference between these two, so we've got cost per hour and we've got the calculated column. You'll see that we've only still got the Power Query one and we've got the calculated column one. We don't have an additional column for the measurement, which we've just calculated. So in essence, we've got the calculation stored somewhere in Power BI, but until we actually call that calculation, it's not going to consume any resources. It's as if it doesn't exist until we need it to exist. Whereas the two columns that we've calculated here, those two will exist regardless of whether we need a calculation on that or not. So I think in the context of this exercise, depending on what we wanted to do, it might have been better to just simply do a measurement, because we haven't actually used cost per hour in any of our other visualizations. So it might be better to limit the columns in our data set and rather just use a measurement. But that is really up to you if you depending on how you would want to do it. So just to give some examples of how these are different. Let's make use of a table. Let's see, let's add test ID in. So we have our 5 different tests. Let's see the cost of the test. This is the sum of that, I think. Yeah, so in total, this was the sum of the cost of test. These come straight from the columns. We didn't calculate any of these. Now let's have a look at the sum of the cost per hour. That's probably not a very useful statistic. We do have the sum of the test there, but actually what we'd probably rather want with this Power Query column is something like the average cost. So things are starting to get a little bit more useful here at this point. So we've got the test ID. In total, this test has cost us in the vicinity of 3 million euros. And the average of this test per hour, if we use our calculated column, is 781.77 cents. If we use the other calculated column, which we made use of, it's the same, because in essence, whether we did it from Power Query or whether we did it from whether we did it from creating the columns from report view, it's really no difference between those two. But something interesting, so this calculation that we've got here at this point doesn't really exist until we go and we add it in there, cost per hour. Now, the first thing that you might notice is that the average cost per hour, as calculated using the calculated columns, gives us a different value as to the cost per hour. And you might want to sort of think of why is that the case? And the answer really is that these two, the one uses the values of the column or the row values to calculate the average, whereas the cost per hour actually goes, and in quotation marks, it looks only at the total costs for CMO 325, and it divides it by the total total duration spent on CMO 325. Whereas these two calculations over here, what they're doing is on a row level, you would remember that we've already calculated all of these values. So we've already got 7406, 73, we've already got all these values here. So all that the average is going to do, it's going to basically take the average of the costs, whereas the calculated measure does the calculation for you depending on the context in which it is applied. And in this context, the context really is the test ID. So we've got our 5 different test IDs. The average cost is 781, but the actual cost was 623.50. So to maybe even make it a bit more sort of interactive, what we can also do is we can use something like we can use something like a card. I think it is a card. Let's drag the measure in there, cost per hour. We can use, for example, a slicer or slicer. Oh, that's not the one I want in there. I'd rather want to use. Oh, that's not good. My TV, my screen's about to switch off. Just give me a second. Okay. Not measurement ID, I'd rather use responsible agent. So now using our measurements and calculations, we can also get the calculations for each one of these individuals here. So the best thing to do here would probably be, let's edit this into action. We don't want this to be affected by it, only this. So we can see the cost per hour that each one of our responsible agents cost us for all the tests that they've conducted. So Aaron Bootman's average cost per hour is 3,000 euros. Adam Bentley, 2,600. Alexander Bennett, 3,000. So you can see sort of how this can be extremely useful in getting a sort of in-depth analysis of costs as they relate to, for example, in this case, individuals, but we could also use measurement IDs. We could use the specific tests to do that analysis. So that really is the measurements and the columns example, and it's a little bit of a trickier one, but I would like you guys to also I think it is the last exercise to do, to also, okay, sorry, I'm gonna go back one, to also do the calculated column and the measure.
There might be some questions that pop up for this one, but and yeah, if I can, I'll do my best to answer those. But yeah, go ahead and you can make use of these formulas here. They should work for the they should work. You don't have to think about those yourself. You can just make use of the formulas that I've put in here so that you don't struggle with the brackets and all of that. Just add those in and yeah, play around a little bit with using a table or a simply a card to display those. But yeah, if there's any questions.
There are.
Yeah.
Text says, could you please show the DAX formula and how it does updates in the table?
Okay, so these are the DAX formulas here. If I go to so let's go with the calculated column. So this is our little sigma sign there with our column. The first part of the expression really is just naming your column. So cost per hour. And a lot of the second part of the expression should be populated if you have selected fact tests. So you can basically say, okay, we want to divide under fact test cost, the cost of test. We want to divide that by the duration of the test. So let's just see. So you go fact, and then you can choose, okay, fact tests. We want to do the cost of the test, and then make a little space there. Use the / as your division sign, and the duration of the test. And then you just hit enter, and that should give you, in the case of a calculated column, you should be able to go to your table view, yeah, and you should see an additional column which has now been created based on this expression that you've got here. That's just for the calculated column. So we're creating a new column in our table view from the report side. The measure looks a little bit different. It says, okay, once again, we name our measurement. It's not a column because it doesn't get created as an additional column inside table view. The expression starts with a sum, because what we're doing is depending on what we're interested in seeing, we're adding up all of the costs of tests. And like I said, and also if you remember the slides, this is a context-aware calculation. So at this point, when you're specifying the DAX statement, it doesn't matter what range or what filter is applied or what slicer is applied or anything like that. PowerBI will take care of that once it's specified. So you take the sum, so you're adding up all of the costs of tests, and you're dividing that by the sum of the duration of the tests. So that would be, you can kind of think about it in a way that the costs of tests here and the duration of the tests here will change every single time you actually filter on something else. So then that calculation is done from scratch every single time you click on that. So it's done on the fly, as it was mentioned there. Within the case of the calculated columns, there are also certain calculations which are done, but they're not, they're based on the rows, the values of the rows in the columns. They're not an expression or calculation which is done from scratch. So it's basically, if you had to think about it in a logical kind of way, your calculated column, what that's going to do is it's going to take Aaron Bootman. It's going to look for everything in here where it's Aaron Bootman, and it's going to take the cost per hour and it's going to find the average of that. Whereas the calculated column, or sorry, the measure
doesn't have a column, it simply is going to go, all right, wherever it says Aaron Bootman, I'm going to add up all the durations that correspond to Aaron Bootman. I'm going to add up all the costs with Aaron Bootman, and I'm going to perform the calculation right there and put it on the dashboard for you. Whereas the other one uses these values, all the row values, the other one does the calculation on the fly.
Great. What are the scenarios we should use the calculated column instead of the measure and vice versa to get the correct calculation?
So that's a good question. So for example, if you wanted to, I think let's actually display that. So I'm going to actually put this one in. I'm going to add another one in next to it, and hopefully if I add the next one in the description will make it maybe a bit more clear. Okay, let's go with cost per hour. Okay, so with this one, you'll see that we've got this value is not really configurable. We've already wrote the DAX statement to be the sum of the costs divided by the sum of duration. So this value will stay fixed. If you're using your calculated column, you can make use of sort of different options. So you can use the sum of the cost per hour, but that's not going to give you the cost per hour. It's simply going to take all of the costs on a row level, and it's going to add it up, and it's going to give you all of the costs. So it's still a useful calculation because it tells us for Aaron Bootman what is the total sum of cost per hour. But something that's maybe a bit more useful would be the average of cost per hour. So what it's doing now is it's looking at all entries where Aaron Bootman is. It's taking the difference, or it's taking where the column that we calculated, and it's calculating the average of that. So this one is the average cost per hour, if you want to think about it like that. And this one is the actual cost per hour, because this one has already taken into account, this one takes into account the actual hours and the actual durations, whereas this one takes all of the costs and it simply averages it. So this one gives you, for example, the average cost per hour, whereas this one gives you the actual cost per hour. Sorry, the average and the actual cost per hour. So for this one, you don't have any of the options for making it a sum or an average, because there is no average. We don't have multiple entries. You've only got one calculation, and that depends on the context in which it's applied. Whereas this one is all about the rows. It's all about the entries, which you've calculated, all about these entries over here. So it really depends on the question that you want to answer. Do you want to work out the average cost of the hour, or do you want to work out the actual cost per hour?
Measures calculated in the memory, not in the table. Is that correct?
I think that's a good way to look at it. Yeah. Yeah.
How do I add columns tools menu?
How do you add columns?
The columns tools menu.
So if you click on fact tests, it should bring up your measures and columns tool.
Great, thanks. Are we getting the actual cost hour by measure? And in case of average cost, is it calculating by column total?
Not column total. Well, yeah, I suppose. So on the calculated column, if you didn't put any filters on it, it would take all of these values here, the cost, all of these costs per hour, all the way down to the end of your value. It would add all of these up and divide it by 6,569. Is that right? 6,569 rows. So it's just going to take the average cost per hour. but the measure takes it will add up all of the costs, get a total. It's going to divide it by the duration, the total of that, and then you get the actual cost per hour and not the average cost per hour.
In what cases should we use calculated column, and when should we use Power Query?
Let me think. I think the best way to distinguish which scenario you want to use them in is if you want your data refresh to be kept in the, or if you want to maintain the calculated column in the applied steps in Power Query, you would do it in Power Query itself. And if you do it in the calculated columns, it's not going to store it in your applied steps. But let me just double check that, because it might be, yeah. So you'll see that in Power Query, we don't actually, let's refresh that and see. Does it actually keep it there? No. So if you go to Power Query, you'll see that that calculated column doesn't exist in your Power Query. It only exists in the report view. So I don't have a really good example of when you want to distinguish exactly between these two, but my initial suspicion would be that if you want to maintain your calculated column during the refresh, you'd rather want to do it earlier during your data transformation or during your query phase. And if you don't want to maintain it as part of your Power Query initial one, and rather only where you're doing your analysis, then you'd rather just keep it there if you don't want to change your Power Query one. But yeah, there was actually something that I had a chat with a colleague about, is there really a big difference between the two? And really it's just one occurs at, you could think about it as a lower level in your queries, where the other one exists only in your report view, but not actually in your query itself. So you won't see cost per hour CC if you open your Power Query, but if you go out of this and you go into table view, then you can see your cost per hour. But this does not come from Power Query. This is a calculated column in your interactive report view of Power BI.
Thank you. If we use the average for both, do we get the same value?
Well, this one isn't an average. It's not an average. You might see in some cases you might get the same value. For example, where there was only one test done, so you won't see a difference between the actual and the average. But as soon as you get multiple tests done by someone, you might see some differences between. I wonder if I could actually see an example of that. That one's the same. Or no, that one's not the same, but it's. Let's see if we click on one of these, then maybe we could get a bit closer. Yeah, so if you had a situation where you've only got one observation, so then you won't get a difference between your actual cost and your average cost, then you'll find the same value. That would be my suspicion.
Hello, can I just elaborate here a little bit?
Yeah.
For my question about the measure. So in the formula, I see that you wrote, for example, the sum for each portion of the data.
Yeah.
So how about if we can just change it to average instead of sum of the two portions, so we can having that the calculated field and the calculated column, and the another one, the measure is the same. So this is what I think about.
That is also fine to do. You've got quite a few different types of options in your DAX expression that you can use. But then what you would be doing is you'll be taking the average of the cost of test for a given scenario, and you're dividing it by the average of the duration of the test. I'm not sure off the top of my head if that would give you the same value, but that's definitely something that you can do if you wanted to divide the average of the cost of the test divided by the average of the duration of the test. You could do that, and that would be useful to do if you didn't want to create an additional column, and you only wanted to get the average of the costs divided by the average duration. Then you could definitely do that. That's fine to do if you didn't want to create an additional column. No problem.
Yeah. One last question. I think I remember something formula about fixed adding. I think in Tableau here. I'm not sure what is, but it is about having that sort of information for having the calculation for each row. I think it's called fixed or something like that. Not aggregating all the information or the data, but having that calculation for each row, as you explained. Adding something, because for example, what the situation I've involved, getting the cost for the salary, for example, for each employee. So I had something like that. I think some mix, but I used the fixed in Tableau, not here.
I used it in
Maybe
Tableau.
Yeah, it was fixed, but I think maybe some.
Oh, we lost the audio, Eamon.
Yeah. I think this is some X or maybe like a level of details. Yes, the same thing.
Yeah, I'm not sure exactly how that would translate into this example here, but I'm sure there is an option for that. I'm not sure if it's called the fixed one. It could be fixed. You can try it. Oh, no.
Fine. There's a question from Estimi.
Yeah.
She asks, they ask, will you talk about how to export share Power BI reports?
Unfortunately not. I can very briefly talk about that. If you guys would, if it would be useful, I can give a quick overview of how that would work. But it's not part of today's course. Unfortunately, I think we only have about 10 minutes left anyway. But I can sort of briefly explain how that would work. It's something that I have actually done. So these Power BI reports that we can create, you can use different let's call them interfaces to embed these reports in for example a website, or to make it as part of a mobile application. So if you want to do a little bit of reading on that, you can look at an application called Power BI Embedded. That's the one. And then there's another online interface. Let me quickly check what exactly it's called. I had it open today. Power BI app.powerbi.com. So just to give a brief look at it, just give me a second. So I'll quickly bring this up. This is not really part of it, but just to quickly show you. So you've got
you can go to, it's an external sort of workspace for Power BI. And in this sort of area, you can configure streaming data sets, and the best thing to do is actually to save your dashboard that you made in using Power BI Desktop. You can import it into app.powerbi.com, and then you've got a really wide range of connection abilities and configuration that you could use to make sure that your reports are always up to date on, if you embed it, for example, on a website or as part of a React dashboard or anything like that. But you won't do that directly from Power BI Desktop. So what you can do is you create your dashboard in Power BI Desktop. You save your dashboard. You have to import it into another workspace, that app.powerbi.com that I just showed you. And from there, you can start looking at exporting sort of HTML code that you can link back to your workspace. And then there's the other one, I think, which plays really nicely with Azure, is Power BI Embedded. And you have to do a little bit of configuration on both sides to make that work. But yeah, I mean, if maybe in the future, I'd be happy to help anyone with something like that. If they want to get in contact, it's no worries.
Zafar would like to confirm that we can also publish the dashboards. Is that correct?
Yes, yeah, you can. But like I just mentioned now, you probably won't do that directly from, if you mean publishing it to a website or something like that, you probably won't do that directly from Power BI, from Power BI Desktop. This is really just a workspace where you create all of that, and you can publish from here. But what you're then creating is you're creating a Power BI file, this PBIX file. That's what I mentioned a little bit earlier on. And this file you need to take to app.powerbi.com or Power Embedded to actually make it available across different resources. So you're not going to be able to make what you create here directly available onto a website, for example, or onto an app, for example. You need to go via a different channel, but you would do that using this publish function, and then it'll give you this file here, this .pbix file, and for that you can then use to do further publishing.
We're almost out of time, but there's a question from Yusuf. Power BI and Tableau share the similar functions and interface. What's the advantage to using Power BI over Tableau?
I wouldn't dare to say if there's really a big advantage. It depends, I suppose, on I think the first place to usually start is what does the customer want? What are they using? What fits in nicely with what they want to do? In terms of functionality, I've worked more with Power BI than I have with Tableau. I suppose it also depends on what you're comfortable with, the costs. I think Power BI is a little bit cheaper, but yeah, it really depends. I don't have a strong recommendation on when you should use Tableau and when you should use Power BI as a business intelligence tool.
Is there a way to use a predefined group of visuals to a variety of data sets?
What do you mean? Like, is there like a place where you can get templates to as your displays, or what do you mean?
I meant, like, for example, now we created some visuals.
Yes.
And maybe it takes time to choose colors, for example, to make it branded for your company or your organization. And you want to reuse the same structure, the same visuals, but change the data because, for example, you get, let's say, another data set that is similar to the one we work with, but and I wasn't sure. I'm doing it, but I'm not sure I'm doing it in the right way, in the sense that, yeah, how to best do that. So that was me.
No, I think that's a good question, actually. So, of course, you can reuse your visuals. So if you have a workspace where you are sharing visuals or collaborating with colleagues on and you'd like to keep the same look and feel, you can always configure and change your get data to import a different data set. If they're similar, especially in terms of column headers, you shouldn't have too much of a problem, but you could definitely drag and drop some additional columns from these or from your new reports into what you're currently using, and then you'll just have to, on a sort of case-by-case basis, see if it's working with your with the visual that you've created. And yeah, but you could definitely reuse them. You wouldn't have to redo all the visuals and all of that all over again, depending obviously on how closely related if you're using an entirely different data set, then it might need to change a little bit, but you can definitely reuse images with different data sets. All right, so
I think that's all the questions we have time for today.
All right, so I'm going to make the slides available to you guys. I actually wanted to do one more thing, but we're not going to have time for that. But this is definitely something that you can do by yourself. Is to actually take a lot of the previous stuff that we did, take the use case that we had right in the beginning, and try and sort of build your own nice little dashboard that answers some of the business questions, or perhaps you have some questions that you thought that might be nice to answer in using a dashboard. But really, what we did now was we addressed topic by topic by topic by topic. But of course, at the end of the day, if you're going to publish a dashboard, a lot of times it's not going to just be a single visual. You might want to create something where there is a lot more information. But that's something that at least we've covered all of the topics. That's maybe something that you guys can try in your own time. And yeah, I think we did at least chat a little bit about some of the other aspects of Power BI. That was some of the questions that were asked were actually, I think, geared more towards the deployment options of Power BI. Is how do you actually now go and make all of this available? And like I said, you can use Power BI Embedded, Power BI Premium. These cost a little bit more money, but they can be used to make your dashboards available. But that is definitely a separate topic from working with Power BI in itself. That's a little bit more also along the lines of data engineering. But like I said, you guys are welcome to send me a message. You can find me on LinkedIn if you've got any questions. I'm always happy to help where I can. Yeah. So yeah, that's, I guess, where the Power BI journey, at least with me and for today, will end. Yeah, so I really hope that you guys had at least gained some new knowledge, and I really wish you all the best with the rest of your Analytics for a Better World journey. I know that you guys have quite a jam-packed, fully packed thing with a lot of new things that you guys are going to be learning. So it really looks like a nice thing, and I hope that I was able to add a little bit of value in that sense.
Thank you so much, Tiaan. There's a lot of comments in the chat thanking you and saying this was very helpful, and they think it'll be very helpful with their work. So thank you so much. Just a reminder to everyone to please complete the survey for this course. It's in the chat. Also, as a short reminder, there was some instructions given for the SQL training on Monday. So please take a look in the Slack channel at the instructions that were given by the instructor, just so to make sure that you're able to follow along, just like with this session. And also keep an eye out in your email. We'll be sharing details about the project at the beginning of next week. But I'd also like to just say thank you again to Tiaan. This was really helpful. He's also on our Slack channel, so he's available there as well. But big thanks, and hope everyone has a great rest of the day.